All right, guys, today we're going to be talking about solving and creating inequalities. Make sure if you're taking notes by hand that you are labeling those notes up at the top. Solving inequalities is kind of like solving equations. You've solved these in the past, so I want you to go ahead and try these first three problems on your own. So if you'll pause the screen and make sure you're trying those, try to refresh your brain on how to do those. If we check out this first one, hopefully you distributed that 4 to everything inside the parentheses. You'll notice that instead of an equal sign, we have that less than sign. But things are going to move across that inequality sign. You're going to use that your inverse operations just like you would if you were solving an equation. When you write your final answer to an inequality, you're going to want to make sure that you include that inequality sign in your answer. That tells you all the values that C can be. So in this problem, it's specifically telling us that C can be any number that is less than 7. So we could plug in 6, 5, negative 19, any of those values that are less than 7 into our original inequality, and we'll balance the inequality. You can also graph the solution set to an inequality. If C is less than 7, we can graph that solution set on a number line. C is any number that is less than 7. So if we start at 7, we change all the numbers to the left of 7. Now notice how that inequality sign does not have a line underneath it. You'll remember that that means that C cannot be equal to 7. It can only be the numbers less than 7. Try out the problem in the middle here. When you finish solving that inequality, you might have gotten an inequality that looks like this. Now, it's usually helpful to have the x on the left side of the inequality. So if I was going to rewrite this solution that I got, I could write this as x is less than negative 9. I brought the x to the left-hand side. I'll notice that the small side of the inequality is pointing toward it. So it's less than negative 9. That means x can be any number that is smaller than negative 9. If you're going to graph it on a number line, it doesn't include negative 9 because there's no line underneath the inequality. It can be any number that is less than negative 9. Let's try out this final problem to the right. I'm first going to clear out the fraction by multiplying through by the denominator, 5. Remember, just like when you've been solving equations over the past couple weeks, that 5 needs to be distributed to every number inside the inequality to keep your inequality balanced. We'd have 3r minus 10 is less than or equal to 30 plus 5r. Now we have no fractions. Keep on solving. Now, just like the problem before, that r is on the right-hand side. You usually want it on the left. So we'll bring the r to the left, flip the inequality sign with it, negative 20. This is telling us that r can be any number that is greater than or equal to negative 20. If you were going to graph that on a number line, you'd have negative 20. It would be a filled-in bubble to show that it can include negative 20 in your solution set, and it is all the numbers larger than that. If you need to pause and check out those problems again, Please do so. Go back over them. Make sure to check in at office hour time if you have questions about them. But a couple reminders about your inequalities. When you're graphing, just like I did in lime green up there, if you either have a less than sign or a greater than sign, in other words, no line underneath, it is going to show up as an open bubble on your number line. If, on the other hand, you have less than or equal to or greater than or equal to, that includes the number on the other side of the inequality. You show that on the number line by using a filled in dot. And just a reminder also, if you ever divide or multiply by a negative, make sure that you flip the inequality sign. Depending upon how you moved your x's in those problems before, if you had negative x's and you divided by the negative in front of x, you would have had to flip the inequality sign to get the correct answer. A couple of tidbits that I find helpful if you mix up your less than and greater than, I always think that the less than kind of looks like an L. Less than looks like an L. The greater than, on the other hand, this is a greater than sign, can be turned into a G. So that's greater than. Might help you, might not, but if you can just remember that the less than looks like an L, then you can know that the other one is greater than. You will need to know the difference. Here in this bottom section, we're going to be looking at special cases, meaning kind of oddball cases for inequalities. Let's try this one out. We're first going to use the distributive property. Make sure that that -4 gets distributed to both numbers inside the parentheses. We're going to add 8x to both sides. The x's cancel out. Now, when you look at these numbers that are left over, you have an inequality statement. 1 is greater than 4. Now think to yourself, is 1 greater than 4? Of course not. So since this is not true, in this inequality, since the x's canceled out and we ended up with a statement that is not true, we would say that there is no solution. You can also use the null set symbol if you would like to. That means that there is no value for x that we can plug into that inequality that would make a true inequality statement. Let's look to the one to the right. In this next problem, we're going to use the distributive property on the right-hand side. It's like multiplying through by -1. And then we need to combine our values on that right side. Again, you'll notice that our x's match each other. So it doesn't matter which one you move them by subtracting, and they're going to cancel out. Now, let's look at our statement that's left over at the end. -4 is less than or equal to -2. Is -4 less than -2? Yes. This is a true statement. Since it is a true statement, that means that any number can be plugged in for x and the inequality would be true. There are infinite values for what x can be. So this is a case of infinite solutions. So, true statement, infinite. Not true statement, no solution. Those are your two special cases that you'll need to be familiar with. Remember, in order to answer if something's not true, or in order to recognize a special case, you'll need to definitely know the less than and greater than signs. Let's flip to the back. On the back, the first thing you'll see is a Venn diagram comparing equations with inequalities. Normally, if you were in class, I would have you talk with the person next to you where you'd recognize things that are unique to equations, things that are unique to inequalities, and then in the middle, things that they share in common. Unfortunately, since we're not in class, you're going to have to try this on your own. I want you to fill in as many things that you can recognize are unique to equations, are unique to inequalities, and things that they share in common in the middle. Pause the screen and fill in as you can. When I was thinking to myself about things that are unique to equations, I would think, well, equations have an equal sign in between. On the other hand, inequalities have less than or equal to, greater than or equal to signs. When you're dealing with an equation, this is something that I want you to get through your head. There is one solution. If it's a normal equation, there's one solution. On the other hand, an inequality has a range of solutions. For example, x is greater than 7. That's telling us that x can be any number that's bigger than 7, not just equal to 7. When you graph an equation, if you're going to graph it on a number line, it would just be one piece. On the other hand, an inequality is going to look like it has some shading. And inequalities, you have to flip signs sometimes if you're dividing or multiplying by a negative. You never have to flip signs with an equation. Things they have in common, things you should remember, they both have special cases. And in both of them, you're solving for a variable. If you came up with other things, that is awesome. Those are just some that I can recognize. Last thing we're going to look at are some word problems. Inequalities occur in the real world scenario all the time. So we're going to see what that might look like here. First problem, we have Sergio. He needs to buy gifts for 8 friends. He wants to give the same gift to all his friends, and he plans to have the gifts wrapped for an additional charge of $1.50 each. If Sergio spends at least $7, he will receive free shipping on his order. Write and solve an inequality to model this situation. So I first want you to stop and think, what is our unknown? What are we trying to figure out? We're trying to figure out, or one thing we don't know, is the cost of the gift. I'm going to make that the value of x. Now, we know that he has 8 friends. Each of them is getting the same gift. We need to take that 8 and multiply it by the cost of the gift. Now, in addition to that, he wants to get it wrapped. So we have to add on $1.50. And it says $1.50 each, meaning $1.50 times 8. If he spends at least $70, then he'll get free shipping. So at least is kind of a tricky one. And when you're trying to determine an inequality sign, at least you think would be less than. But when you think at least, we want the total cost over here to be more than $70 in order to get that free shipping. So at least actually means greater than or equal to. If we kept on solving, you should get at the end, x is greater than or equal to $7.25. Now, I want you to take that and make sure that you're able to put it into a sentence, what it means. What this means in this case is that he needs to spend at least $7.25 on each gift per gift to get free shipping. Let's try the one in the middle. Zachary charges his music students $25 per lesson, plus a recital fee of $50. $25 per lesson, plus a recital fee of $50. How many lessons can the students take if she pays, or he pays, no more than $175? Go back to the problem and try to figure out what your unknown is. They tell us how many lessons. So X is the number of lessons that Zach can take. And now let's try writing the inequality. Each lesson costs $25. So 25 needs to be multiplied with the number of lessons. Not only that, what else is he being charged for? Well, the recital. He wants all of this to total no more than what? Look back at the problem. He wants it to total no more than $175. So we need this total cost on the left to be less than or equal to $175. See if you can finish up solving from there. Hopefully you were able to get X is less than or equal to 5. What that means, Zach can take up to 5 lessons. If he takes any more than 5 lessons, then it'll cost him more than the $175. In our last problem to the right, we're going to give this one a shot. We're told that the Daily Info charges a fee of $650 plus $80 per week to run an ad. The People's paper charges $145 per week. For how many weeks must an ad run for the total cost at Daily Info to be less expensive than the People's paper? First, define your variable, X. If you go back to the question, it says for how many weeks? So X is the number of weeks. We're trying to figure out how many weeks is it going to be for the Daily Info to be less expensive than the People's paper. So we want Daily to be less than the People's paper. Now they both have different ways of charging. It tells us in the problem that the Daily Info charges a fee of $650 plus $80 per week. We don't know how many weeks that's going to be. We want the Daily to be less than the People's paper. The People's paper charges $145 per week. Remember, per means multiplying. So $145 times the number of weeks. Let's go ahead and take a minute and solve that inequality. In the end, you should have gotten X is greater than 10. Double check your work if you need to with my equation solving before. And you need to write what that means in a sentence. The ad must run for more than 10 weeks. In order for the daily paper to be less than the People's paper. If you need to rewind and check out any of those again, you're more than welcome to. Don't forget to log back into office hours if you have questions on anything. Otherwise, check out your assignment.